Good afternoon. Dr. Mesa's Engineering, Econ, and Planning, CVE 4000 kids. Our group decided to do the Euro Tunnel, aka the Tunnel. Presented by Devyn, Clute, Cohen, Diallo, Farquharson, Mary Gormley, and Anton, Saunders. In this presentation, we will go over the following: the project background, the key costs/benefits, the key issues, the key design/implementation decisions, the current status, and the discussion and criticism. The first 5 objectives were done by each team member, and the 5th one was done collaboratively. The project background. The Channel Tunnel is a 31.4-mile long tunnel that connects Folkestone, England, and Sandgate, France, under the seabed. The idea first began as an underground highway for horse and carriage in 1802 by an engineer named Albert Matthew. The idea of a railroad connection between the two countries was discussed about until the 1980s, when the idea was actually carried out. Above is a picture of Albert Matthew's idea of the horse-drawn carriage. The British and French side both needed to dig and meet in the middle. The British side was called the Tunnel Tigers, and the French was called the Underdogs. The margin of error allowed was about 6 feet, but with their laser technology on both ends, they were just 2 centimeters off when they finally met. The British and French met in the middle on December 1st, 1990, which is pictured above. The construction was not a walk in the park, but both sides had to deal with water leaks due to the fractured rocks that was not foreseen in the geotechnical reports on the British side. In 1988, construction started in both countries. The final project was completed in May 1994. It cost about $11 billion, which is almost 2 times over the original budget of $5.5 billion. There were 3 tunnels that were dug out. 2 were for train cars for passengers, and the other was a service tunnel. The lowest the tunnel goes under the seabed is 250 feet, with an average depth of 150 feet under the sea floor. The train ride takes approximately 35 minutes.
The cost and benefits section. The Eurotunnel's cost was initially $5.5 billion in January 1986. Its benefits were to inspire economic development, improve European trades, and provide an alternative high-speed transportation method for existing modes. The actual construction cost was $11 billion. The Eurotunnel construction estimate is displayed below. It shows the breakdown of the elements analyzed for construction with their prices. Unfortunately, the actual cost of construction increased by 99% compared to its original bid price. The enormous price rise was due to many factors, one of which was the development of an international services department in the tunnel, which accumulated to alone $2.1 billion. Other funds went towards the necessity for an enhanced safety and environmental standards, and since it was partially a fixed cost contract, any changes would escalate the price. The predictions for the utilization for both passenger traffic and freight traffic in 1993 and 2003 are shown. The data indicates that a significant number of vehicles will be used for the tunnel in the years after its construction. It should be noted that a major benefit of building the Channel Tunnel was to lead to an increase in the toll transportation market over the projected 10-year period. The user benefits were analyzed based upon the total time savings and fare reductions in comparison to both ferry and airline transportation. Both competition frameworks were based upon the methods specified in the Value of Time and Operating Cost Guidance of June 2004 from the Department of Transportation. The net present values represent the calculations of user benefits based upon the total travel time savings and the benefits from fare reductions. In each case, the NPV were positive, suggesting the income gained would be greater than what could be gained at the discount rate.
Major issues. A major issue that affected the project evaluation was the mode of transportation used to get from France to Britain. The project either called to bridge over or tunnel under the English Channel. A bridge came with an ease of construction and less uncertainties than beneath the soil. However, the channel is the busiest waterway in the world, so the bridge would have to be high enough for boat clearance and strong enough to resist impacts. Ultimately, a geological report found a chalk and clay combination that was very accommodating for tunneling. Issues arose in the amount of money that was going into the project in order to produce a design that would last with minimal updates. This is made easier if the design is constant. However, the ground conditions change from one end to the other. An example would be the different waterproofing systems used near Britain that contain fewer bolts and way fewer segments. This organizational chart shows the original solution to logistical factors that affected this project. External influences such as banks, safety regulators, legal authorities, and other active stakeholders had high influence. The internal influences were the 10 companies that were formed into 2 different joint ventures, the French Construction Company and the British TransLink JV. These were combined to form the TML joint venture. This is the joining of companies with different ideas on how to create the channel, which causes a lot of discrepancies in the engineering design. The timeline was a major issue because the whole project was planned to be finished in 8 years. This means that different civil works overlap by years sometimes. Also, temporary ventilation, lighting, and structures had to be engineered along with the final design.
Decisions. 2 of the most important design considerations will be highlighted in this section. The first, as in any construction project, is public safety. The traveling public, as well as a large investment, must be protected. These were accomplished by design of detection systems as well as a service tunnel, which provided passengers a safe escape during the August 21st tunnel fire. The geological location was important because it affected the length of the tunnel to be designed as well as the depth. 2 decisions regarding implementation will also be highlighted. The contracts required workers to get approval from both governments for certain issues, which had an effect on work efficiency. The choice of awarding fixed-price contracts was not a good decision, as it put the contractors at a disadvantage when unexpected and costly problems arose. Communication was extremely important in the implementation phase because the varying backgrounds of the workers could have led to misunderstandings and therefore many requests for information. The method of ensuring tunnels met at the same point as well as a common construction standard also had to be determined.
Objective 5 required presenting the status and results of the project being researched. Construction for the Eurochannel Tunnel began on February 28, 1988 and lasted for 6 years. The first successful test run occurred on December 10, 1993, and the tunnel officially opened on May 6, 1994. The services offered by the Eurotunnel include a roll-on, roll-off service for vehicles and its passengers, passenger trains, and freight trains. Roll-on, roll-off refers to the transportation of wheeled cargo, including cars, trucks, trailers, etc. Before completion, the Eurotunnel was predicted to have 16 million passengers within the first operating year. Competition from airlines and overestimating resulted in a much smaller first-year volume being only 3 million passengers. As seen in the table provided, traffic volume has gradually increased in the past 5 years and continues to increase each year with time. The tunnel is operating efficiently to this day and has received over 80 awards throughout its 24 years in operation. It was named the greatest infrastructure success of the 20th century, and it was also acknowledged by the International Railway Organization for being an example of safety in the transportation world. The Eurotunnel is the only railway not to have had any major accidents within the past 7 years, and that is out of railways throughout 22 countries.
Discussion and criticism. The Channel Tunnel takes 35 minutes to get between the 2 countries. The ferry ride would take 90 minutes, and flying would be quicker, except the normal procedures that flyers have to go through, like security, take more time than the tunnel. In the cost and benefits section, the prediction of the revenue produced was severely overprojected. The ferries and airlines lowered their costs, and the tunnel could not compete.
Most of the issues occurred in the implementation process could have been avoided if there had been a contract which was well defined and written in common language where both parties were familiar. The fixed price contracts is one of the riskiest types of construction. Every time they had to change something, the cost of the project would go up, which is why they were extremely over budget. A greater analysis of the competition should have been conducted for fair implementation to consider how the system would do compared to its counter travel modes.
The cost-benefit appraisal of the tunnel revealed the British economy would have been better off if the tunnel was not constructed. There are many unforeseen incidents that made travelers wary of traveling on a train, like the fire in 1996. The tunnel rail systems kept shutting down due to the cold air of Paris and then entering into the warm tunnels. Another reason the tunnel shouldn't have been built is because it took almost 10 years for the tunnel to break even. Overall, this project could have been better off if not constructed.